Hey everyone, thank you for joining us today on our webinar around IFCs, unlocking industry foundation classes for your organization's path to digital integration. My name is Schemas Structure, and I'm joined today with my colleague Stephen Conlon. Stephen's just going to give you a bit of a run through here on Pentagon's line of business and for today's agenda.
Yes, thanks, Seamus. So our line of business here, we got our wee digital integration wheel for Pentagon. So some of you on this call probably are familiar with Pentagon's line of work, but yeah, so we've evolved in data management and document control, change of management of digital assets, managing and setting up BIM CDEs. And then in relation to today's webinar, this ties into digital project collaboration and asset integration. So now I'm going to go through just the agenda. So you can see on screen now the agenda for today's webinar. So we're going to go through what are IFCs, who uses them, and why they're needed, the importance of structuring IFC file, the ISO compliance, openBIM, and IFCs, and then how us here at Pentagon can actually support you guys in your IFCs. So now I'm going to hand you back over to Seamus, who is going to introduce us to IFCs. So take it away.
Thank you, Stephen. So what is an IFC? IFC stands for Industry Foundation Class. It's a globally recognized standard that is developed and accredited by Building Smart. It provides a structured approach to managing information through the use of set definitions for all types of objects that we encounter within the construction industry. It is a non-proprietary file format which can be used across multiple different BIM authorizing and viewing tools. As the image may suggest, IFCs are able to be plugged into these different softwares to allow for full connectivity and data integration. So how are they used? IFCs facilitate the exchange of building and construction data between different software applications. Software should never dictate the informational output of a project. As an example, we may work alongside the likes of Graphisoft, Autodesk, or Tekla sales softwares. However, in reality, each of these softwares have their own specific unique outputs, and the information around these here softwares should not be driven by that software. With IFC being a non-proprietary file, it allows for the integration and referencing of the information across all these platforms, especially when we start to consider the likes of coordination and ensuring everything is aligned correctly. This allows for better collaboration between different teams while working within a project, as everyone has access to the same information. Steve, can you give us a walkthrough on how IFCs are used in the AEC industry?
Yeah, so a lot of professionals in the AEC industry use IFCs. So, for example, architects utilize IFCs for seamless exchange of building design data across various software tools, enhancing collaboration. We've got engineers such as structural, MEP, civil, who employ IFC to merge their design data with architectural models, ensuring coordination. We've got construction professionals like contractors and managers rely on IFC for accessing design and construction information. We've got facility managers who leverage IFC to manage and maintain built assets throughout their life cycle. And then software developers in the AEC industry create applications supporting the IFC standard for data interoperability. So now I'll talk a wee bit about collaboration between different softwares. So interoperability between a software developer and their other softwares, it should be a streamlined process. However, this is not always possible due to information requirements or when working with a third-party contractor. This is apparent when if you consider like Tekla steel suits a specific requirements. However, this may need to be coordinated with a Revit or ArchiCAD user. So you can see on screen that we've got Revit to IFC to ArchiCAD and Tekla, and then back to IFC to Revit. The same with civils to IFC to Bentley, back to civil, back to IFC. Now, civils 3D and Bentley aren't actually certified by Building Smart yet. But IFC format provides a way to integrate the requirement information to these third-party software or third-party software developers. So I'm going to ask Seamus a question now. What do you know from your experience integrating IFCs from different softwares?
So in my experience, primarily working within the Revit space and within the MEP industry and discipline, Typically, I'd be asked to coordinate and use specific elements from the likes of an AutoCAD user, an architect. Mainly, that will consist of the likes of spatial information, which is always critical for the design components of a project. Having this information readily available is always critical and vital when considering even the likes of COBie requirements and COBie component information. So it's important that I'm able to populate my project accordingly and that my building assets actually have the specific location markers associated with those components. This leads me on now to look at different types of IFC workflows. Again, IFC workflows will be dependent on software. However, as a generalization, it does look something like this. The IFC file should be used as a referencing file for coordination, both for graphical and non-graphical. The IFC file then can be used to extract specific information, relative to your project. Again, in this example, likes of an MEP user having to use spatial information with an AutoCAD user. Once the information has been extracted from these IFC files, I'll be able to populate my project with that information and then create an IFC export from that, allowing me to append these here models for coordination through the likes of a different viewing tool. So just as a bit of an example, I've prepared a video on this. As you can see here, I have a LinkedIn IFC file. Again, doing my normal checks, ensuring I have my building room bounding information. It's essential when working with the likes of referencing file that I'm able to actually extract specific space information. Right away, we can see there's a problem. 73 spaces have been created on this one level. Now, when I try and actually extract, specific element and room names and room numbers, I can see that it doesn't actually carry across, doesn't give me anything. So I have to kind of consider what I'm going to do next from here. With the likes of AutoCAD, IFC files to Revit, there is an integration process. Sometimes it doesn't work as streamlined as you want, and you have to consider other methods. In this case, I used a different process where I was able to carry across all my spatial information from AutoCAD, which I can now use within my Revit project. As you can see, the information about my rooms and numbers have been updated accordingly. This is great, as now I can start to use it either at the point in the project where my project's already existing, or I'm starting my project off fresh. This lets me now start to load it in and then start to use that information for, again, with the likes of COBie information. When we start to consider the likes of, integrating civil models or Tekla steel models, there is a different integration and coordination process, which may be around internal origin-to-origin points or using the likes of different survey points. As you can see here, doing the same checks again, linking in my model, using my space information, and then actually this time when I have it linked in, I'm able to acquire the specific information relating to my rooms and my numbering. In this particular instance, the model has already been completed within the AutoCAD file, so there's no need for me to actually recreate this information, which is a major pain point as an MEP user who previously would have to try and create walls or use other viewing tools and then associate those walls and information together. It's a good way of identifying the disconnect between these softwares, and using the IFC is a good way we can actually promote this interoperability. This here now leads us on to what is an IFC schema. So IFC schemas are structured with different versions. Each version has a different set of rules and definitions and specifications for the exchange of information within a BIM environment. The IFC schema is not a new concept and has been developed from the 90s. However, it's becoming a lot more apparent within the recent years, as we look towards the likes of openBIM and BIM interoperability. The newest addition to this here is IFC 4.3, which has expanded upon infrastructure classification and association of elements. Stephen's going to be able to walk you through now the infrastructure classification. This is just a brief now on different data schemas and their relationships within the project. IFC object definition represents all entities. IFC relationships summarizes these relationships between the entities. An IFC property definition describes the properties associated with these entities. Stephen will now walk through how IFC object definition plays a critical role in the IFC structure.
So we can see there from the diagram on screen that we can see how from the IFC object definition it expanded into subcategories such as IFC object, IFC type object, IFC context. Then we've got our IFC object, which is then has subcategories such as resource, product, process. Now, this is a detailed approach which allows for a granular approach to information containers associating relative information for the project. Now, IFC schema is complicated and has many inverse relationships. So we don't actually have the time today to actually deep dive into all this. But however, if you want a better understanding of these relationships, please don't hesitate to contact our digital integration team. So now what we'll do is we'll go on to our layer structure. So IFCs have many layers, nearly like an onion. And when you try to peel it back, it can make you want to cry if you don't know what's going on. But once you have a better understanding, it is a structured approach. So on screen, we can see there's four key layers which go into an IFC, and each layer is built upon each other from most generic to discipline specific. So we've got first got our resource layer, which is our base or our building block. So it's the basic building blocks of the IFC. So this would be such as unit definition, shape geometry, date and time description. So a very generic. So then we've got our core layer. So the core layer is also quite generic, which brings in basic objects such as property sets and different types of relationships, which can apply to any industry. Then we've got our shared layer. So this is where things get more down to earth and contains the most common objects in AEC. So it's in this layer you'll find physical things such as walls, stairs, windows, those sort of things. And then we've got our domain layer, which is the discipline-specific stuff. So as of IFC 4.3, it covers disciplines such as architecture, construction management, electrical, plumbing, structural, roads, rails. So basically, in essence, the shared and domain layers are the layers that the AEC professionals would recognize. So when I teach someone about IFCs, it actually makes more sense to start off with these layers because otherwise the people that you're teaching might get lost or turned off by the highly abstract nature of these layers. So I'm now going to pass you back over to Seamus, who's going to go over implementation guidance for IFCs.
Thank you, Stephen. So IFC implementation guidance should be considered as a performance standard. These IFC guidelines should be used as a guideline to go through the different types and how IFC formats should be used with the likes of IFC XML and how IFC is currently being developed. These guidelines are constantly being updated and adapted to improve the data exchange, and these guidelines can be found within the Building Smart website. However, the most recent IFC schema is 4.3, which has major changes compared to the previous schema. IFC 4.3 is the most recent addition, and in this schema, it focuses primarily on infrastructure adoption and the different classification issues that they've previously had. So, Stephen, how do you think IFC 4 differs?
Yeah, there's been key changes in the IFC schema for 4.3 for infrastructure. So IFC 4.3 represents an undeniable breakthrough in the AEC industry. This new version of the standard brings with it a series of key modifications and enhancements that have significant impact on infrastructure projects. So the primary goal of IFC 4.3 is to expand the schema to provide a detailed description of infrastructure projects in areas such as railways, roads, ports, waterways, and then including common elements for these fields such as geotechnics and alignments. So you can see the domain expansions covered by IFC in the wee diagram on screen now. But now I'll actually go through a few examples of these key changes. Firstly, IFC alignment. This is an element of the IFC standard that allows precise description of longitudinal objects in infrastructure projects. Then we've got objects. So this latest version of the standard introduces many objects that allow for more detailed description of elements found in infrastructure projects. So you can see in the wee picture on screen, you got your IFC curb, IFC pavement, IFC rail. So there's a good few things that have been added in there. And then finally, we've got our spatial elements. So in this latest change in the IFC schema, this introduces spatial abstraction objects so we can better organize our models. So this allows for clear communication and structuring of the project division, because previously in the case of infrastructure projects, there was a lack of this possibility. So now what I'm going to do, I'll pass you back over to Seamus, and he's going to go over NVDs with you.
Thank you. So if you are a Revit user, you're very familiar with the dialog box on my left. This dialog box shows many different IFC exports and different versions. This includes IFC 2.3 and IFC 4, alongside the options such as coordination or structural and MEP. It is vital when completing an IFC export that your settings are correct. So as an example, using the likes of IFC 2.3 coordination will differ over IFC structural. These differences are classified as MVDs or model viewing definitions. These definitions play an integral role when exporting and populating your model with IFC information. As an example, we can use the likes of a structural MVD on an architectural model. It will not populate that model with relevant information, both graphical and non-graphical. So another way to consider how these MVDs or schemas work is if we consider the image on the left to be the full IFC schema and an individual cube to be an information container relative to a specific discipline. We were able then to make a comparison based on what information is relative in the likes of a coordination MVD, as opposed to what information is relevant in a referencing MVD. Again, this is really important as we are able to create our own custom MVDs, but this will be quite dependent on what discipline you're working with, what elements you have within your project, and what are the informational requirements that you have to meet. So now the question is, why are IFCs relevant as information containers? This lets us kind of look at the different ISOs associated with them. In addition to adhering to ISO 19650, it is essential to recognize that IFC has its own specific ISO, which is ISO 16739, and the realm it lives in relation to building information modeling. ISO 16739, commonly known as the IFC standard, serves as a fundamental framework for BIM data exchange and interoperability. This internationally recognized standard establishes a structured and systematic approach to building information, facilitating seamless communication and collaboration across various software platforms. Unlike ISO 19650, which primarily focuses on information management processes, ISO 16739 provides a specific data schema and format for representing building information, ensuring consistency and compatibility throughout the lifecycle of the building's assets. By understanding and implementing both ISO 19650 and ISO 16739, organizations can streamline the BIM workflows and enhance efficiencies in the project management for delivery. So what are some of these benefits? Through this structured data exchange, IFC facilitates seamless communication among stakeholders and streamlines the facility management process, aligning again perfectly with ISO 19650 standards and its specific information requirements. The use of IFC complies and establishes a standardized framework for representing building information, and this standardized approach ensures that data can be effectively managed and utilized in accordance with ISO 19650 guidelines throughout the asset's lifecycle. Embracing these requirements empowers your organization progress towards ISO certification, providing a competitive edge, improving operational efficiency, and fostering enhanced collaboration for projects. So I'm just going to hand you back over to Stephen here now to look at the likes of IFC and openBIM.
Yeah, so just the relation with openBIM and IFCs, we're looking towards the future of a project, so we must consider openBIM and future-proof our project, especially at the facility management level. An openBIM approach to the design, construction, and operation of buildings is based upon open standards. So the methodology supports transparent, open cooperation of all project participants, regardless of the implemented software. So with IFC being a non-proprietary file type, it is the best solution for openBIM as it doesn't allow software applications to define the data exchange. So you can see on screen with closed BIM, so that'll be from Revit to Revit, ArchiCAD to ArchiCAD, or Tekla to Tekla. But really where we want to get to is openBIM, where it doesn't matter what software you're using and we can seamlessly and efficiently exchange data. So I'm now going to pass you back over to Schemas, who's going to go over how Pentagon can help you with your IFCs.
Obviously, working within the digital construction industry for over 20 years, Pentagon has been able to help create and set up different projects and different export options relating to IFCs. This leads then obviously into the likes of how we can start to integrate the IFC files into your project, look at different interoperability solutions, and how we can correctly coordinate these projects and extract the specific information related to those projects. Sometimes it gets difficult to try and understand the different client requirements and the different ISO standards associated with that there. And this obviously leads into the likes of quality assurance and data validation and testing. Managing IFC data has always been difficult, especially for the owner operators. So we want to start working towards future-proofing your projects alongside openBIM. Pentagon is here to help your projects with the likes of different support and workflow developments. Thank you for joining us today. We really appreciate your time. We're here now to take a few questions. The first one's from Paul Turner. Paul writes in, did you use a Revit add-on from AutoCAD to input and export IFCs better into Revit, into and out of Revit? In this particular scenario, I did, Paul. You probably, if you are a Revit user, you're very accustomed to the likes of when you start to integrate IFC AutoCAD files into Revit. Sometimes all the space information doesn't fully go over, obviously due to the way floors are created and walls are created. However, in this particular scenario, I was able to look at the AutoCAD file itself and use that specific plugin for this here, which allowed a much more streamlined process and full information going across. On saying that there, this IFC file was direct from AutoCAD website, and in my experience, almost all the information typically goes across. Again, we are able to use the likes of different integration tools and validation checks, with the likes of open IFC viewers to confirm to make sure that all the information was actually properly carried across. We have another question here from Kieran saying, aren't IFC files very large and PC resource hungry when compared to other models and other formats such as NWDs, etc.? Can we advise on how file size can be managed with IFC files? It's a great question, Kieran. I suppose it really comes down to what stage of the project you're at initially. This will consist of, if you're at the coordination stage at the early on, what information actually needs to be, brought into your project and brought into your model. And the IFC files themselves are quite large, but again, it really is quite dependent on when they should be used and how they should be used in relation to your project. Now, again, when we do consider the likes of, Navisworks files and cache files, it is important to look at, what stage of project we're at and how they should be used then.
Yeah, so we've got another question here. So this is from Robert. So is it possible to get an IFC exported from Tekla in his instance in a shared coordinated position? Currently, he has to export an IFC and bring it into Revit to acquire shared coordinates and then re-export the IFC so it works for a client. However, this usually makes the IFC size up to double the original size.
Yeah, you are able to coordinate the likes of your Tekla scale within your project. There will be different methods involved in that there. Obviously, the major one is it's easy for anybody to really move and link a file into the correct position. But like you say, we haven't got the shared coordinates from that. The main thing from that there is kind of looking at what is the integration process initially from your IFC file to Revit. Has the project base point been initially set up in that instance? Although the file does become quite large, again, it should be used as a referencing file. May be a point where your Tekla Steel project, when IFC doesn't need as much information actually attached to those specific elements. Again, Tekla Steel being a structural analysis software and framing software, it's key to, at those important stages, making sure that only the relevant information is actually meeting yourself. And in the case of, when we go back and revisit the likes of MVDs, has it just been an export of everything, or has it just been an export of, specific elements, which obviously in this instance you need primarily for coordination? Now, again, the file size is an issue once it's originally appended, but it should be used when working with it. You can always have your model obviously appended in your model and unloaded as and when required, obviously for the likes of processing power and that kind of thing. Any more questions, guys? By all means, contact info at Pentagon Solutions. or contact one of our digital integration team. Thank you very much for today.
Yeah, thank you.